conversion, purification, and utilization of biogas from pulp and paper mill effluent. This presentation is a reflection of, with the co-authors, you can see that it's a reflection of the synergetic efforts between the technical institutions like CPPRI, technology providers like PACE, and the industry like Sensors, and another technology provider, Knowledge Integration Services Bengaluru, to convert this biogas into a useful product. As you know that the increasing cost of energy in recent times has resulted in adverse impact on the cost of paper production, because energy constitutes around 40% of the paper production cost, and as a result there has been need for energy conservation or exploring alternative sources of energy to ensure sustainability. And one of these routes is through biomethanation of mill effluent, and it utilizes as fuel or power. 3 tons per day kraft paper, utilizes agro residues and waste paper, has a full-fledged ETP approved treachery treatment, but still the mill was having problems in meeting the discharge norms. And it has a consent to utilize the treated effluent for irrigation and plantation only. They have the USB reactor. After a lot of deliberations, this internal circulation reactor was chosen, and it is a new dynamic reactor because the main advantage is that it has a wide range of flexibility from 1000 milligram per liter to 20,000 milligram per liter COD can be treated, and can be incorporated as a pre-treatment step for conventional aerobic treatment for handling the backwater of the paper mill. And you can see this next slide. There is a two-phase. It is basically evolution of upward enable sludge blanket and extended sludge blanket digestion system. The biogas is separated in the biogas is separated in 2 stages in a reactor with a high diameter ratio and gas-driven internal circulation system from the bottom. And this internal circulation ensures efficient substrate and biomass contact, which improves the degradability of the substrate. And in recent years, it has been adopted in various industrial sectors. And this is a two-phase. The lower phase is the internal circulation, where there is a high turbulence, high sludge activity, and these are gas-water separation. And the upper phase is the granular water separation, and you get a biogas from the top. And the possible volumic rate is 2 to 3 times of the USB reactor, which was earlier used. The system can process high upflow liquid and gas velocities, and the diastase typically produces biogas with a high concentration of methane to 80%. And the co-generation of energy as a biogas and treatment of wastewater and reduction in pollution load achieve help in environmental compliance. And this is basically the design specification, which is designed for treating around 4,500 meter cube per day of effluent, and around biogas generation is around 6,000 meter cube per day, and the COD reduction is around 65 to 70%. That means it is around, and biogas is around 0.45 meter cube per ton of COD reduced. And this is basically the system where the wet washings after going through the bioclarifier is treated to cooling tower, because the microbes are basically mesophilic, so the temperature etc. has to be maintained, and then after this treatment in the bioreactor, this is flared, and the rest treated effluent after post-treatment goes to the conventional activated sludge process, followed by secondary and tertiary, and then the mills are now able to meet the norms. Apart from this is all the different, this is the conditioning tank where all the chemicals and are added to provide the macronutrients, micronutrients, and this is the bioreactor, which is IC reactor, and they have this what you call the gas is stored in the this biogas holder, and the biogas is further flared continuously at present. The plant was commissioned in March 2021, and now we have after over 1 year of operation and continuous monitoring by CPPRI, the average COD was around 50 to 55%. And since April 2022, the paper machine backwater is also being introduced along with the wet washing. So now it is running on the full capacity, and this is the average performance of the biomethylation plant, and you can see that the final discharge characteristics are well within the norms that is stipulated by the regulatory authorities. And this is the performance for over last 1.5 years, where you have the COD is basically around 60 to 70%, and the biogas is around this 6,000 meter cube per day. And the impact of the biomethanation before and after, you can say that after biomethanation installation, the cost of effluent treatment has come down to around 40 rupees as compared to 63 rupees earlier. And now the way forward has been the next step to convert this biogas into the compressed natural gas system. As the biogas generated contains 60 to 70% methane and the rest is carbon dioxide. It is compressed to, the plan is to compress this biogas to around 98% methane concentration, which can be used as an alternative fuel. And this mill has already undergone an agreement with this HPCL to sell the generated biogas post-purification under the Sustainable Affordable Transportation Scheme of Government of India, where they provides subsidy for setting up the compressed biogas plant and as well as the purchase of the compressed biogas. And my friend from KIS is already there. He will be covering in the next his presentation the details of the system. And this biogas plant is around 3 ton per day capacity, and it is being installed to involving H2S scrubber and CO2 removal by pressure swing adsorption system. And this biogas will be compressed to 250 bar pressure, and then it will be used for as a compressed biogas for the vehicles. And this I am just because he is here already, so he will give into detail about the H2S scrubber system and the other the biogas compression system. And the four tower this PSA CO2 removal system. And this is the what you call the return on investment expected, because the total operation cost is around this 2.9 crore, while it is total revenue is expected to be around 5.6. So, and the total capex is around 7 to 7.5 crores. So the return on expectation in investment is around 2.6. So, and the utilization of this biogas generated, say taking as 6,000 meter cube day by compressing biogas, it will help in reducing that we have calculated around 157.7 kg per day, or you can say 57,740 kg per annum greenhouse gases emissions, tons equivalent carbon dioxide. This system is also being included as this IC reactor is also being incorporated as an integral part of the waste paper business. Since I am at Vapi, and thank you, Vapi, it was a pleasure coming here and with so much hospitality and affection. So many mills have gone for ZLD in the recent substance, but there were the problems of odor and high COD and TDS buildup. So recently some mills have gone for this biomethanation system, waste paper based mills, because this IC reactor has what you call the flexibility from 1000 milligram to 20,000 milligram per liter COD. So they have incorporated this by some like Sunshine paper mill and this Akshara paper mill and many other paper mills are recently going, where they have incorporated this. So they are now able to maintain a COD level of optimum COD level around 5,000, 6,000 milligram per liter, and BFA has also come down. H2S and this odor problem has been reduced by incorporating this in the waste paper based mills also. So that is the beauty of this system, and so that is the conclusion. Merits already, whether it is USB or IC, merits are universal, and what you call this, it reduces the footprint than the conventional anaerobic treatment, and the sludge generation is less, and the conversion of biogas into compressed biogas will indeed be a significant step in improving the cost economics of the biomethanation plant as well as reducing the energy footprint. So this CPPR is a technical institution, PAICS India, KIS, Bengaluru, and Ascensions. So this is one of the good example in recent times where all have worked together synergetically to address to a common goal of achieving environmental compliance as well as in reducing the impact of the pulp and paper mills on the environment. So that's all. Thank you so much, and I invite whenever somebody help. This is our CPPRA campus, so it is a green campus, and come sometimes and enjoy our hospitality also. Okay. Thank you so much, and thank you.